Hi, and welcome to today's lesson where we will be translating algebraic expressions. We're going to be taking expressions that are written in words and translating them to math symbols, or we may be taking some that are in math symbols and going backwards, translating those over to words. So before we begin, let's just get a few definitions. Our first definition that we want to know is what a variable is. A variable is any symbol, usually a letter, that will represent some unknown quantity in a problem. We tend to use variables like x or n. A constant is a quantity that does not change. Those are our numbers. 5. 5 is a constant because it is always worth the same amount, 5. An expression. This is what we're going to be focusing on today. An expression is a mathematical phrase that can contain numbers and or variables. In other words, it can contain numbers, variables, or both, operations like addition, subtraction, multiplication, division, exponents, and grouping symbols. There are two types of expressions that we're going to talk about. The first type is a numerical expression. A numerical expression contains numbers, but it does not have any variables. So some examples of a numerical expression might be something like 5 plus 3, or 9 times 2 plus 7. An algebraic expression will contain variables. Some examples of algebraic expressions would be x minus 3, or 3 multiplied by 2n, or 4 divided by m plus 1. Notice that each of these expressions has a variable in it. In expressions, there are going to be many different ways that you may see multiplication written. AB, A times B with a dot between it. Parentheses can also indicate multiplication. Notice the difference between that one, both of them are in parentheses. We can still use the x that we learned back in elementary school. Division, on the other hand, will be written in one of two ways. We can write it as a fraction, or we can write it with the little division sign that we learned earlier. We tend in algebra to use the fraction symbol. Here are just some of the many phrases that we're going to be using when we talk about translating algebraic expressions. Notice that in the first row of each of those, there's a star by those words. We have sum, difference, product, and quotient. These words are important because what they mean is the answer to that type of problem. This will be important as we are working through some of these because sometimes that means I have to do that operation first. So when I see the word sum, difference, product, or quotient, I know that that means the answer to that type of problem. So sum is the answer to addition. Product is the answer to multiplication. There are some other words that we need to talk about here, and those are included in the subtraction: less than and taken from. The reason these are important is that they actually switch the order in the problem. For example, if I said 5 minus 2, I would write the 5 first, then a minus sign, and then the 2. But if I said 5 less than 2, that means I started with 2, and I'm going to subtract 5. So I have switched the order. That's the same with taken from. If 5 is taken from 2, I started with 2, and I'm subtracting 5. So these two are important because they switch the order. That would also be true for more than, because more than, the word than, is what tells me to switch that order. So look for things like than or from, and they tell me that the order is switched. Okay, so let's just write a few algebraic expressions together. The first one is pretty simple. It says m increased by 5. And we know if we increase, we're adding. So this is m plus 5. and that would be my answer. Second, the quotient of a number in 12. If we go back, we know that the quotient means the answer to a division problem. So this means we're going to divide some number by 12. Now we don't know what that number is, so this is where we use a variable. We can use any variable we want. I'm going to use n to represent a number, so n over 12. We like to use the fraction bar to indicate division. 11 less than 4 times a number. Now this is where we have to be careful. Remember, this is less than, which means to subtract. But because of the word then, it switches order. So I'm subtracting 11 and 4 times a number. But I have to switch the order. So 4 times a number should come first. So 4 times some number, 4n, minus 11. 2 more than 6 times a number. Again, more than switches the order, but this time it's adding. So we're going to be adding 2 at the end of the problem. 6 times a number goes at the beginning of the problem. So 6 times a number plus 2. 7 times the sum of a number and 3. This is the kind that can be tricky sometimes. We are supposed to be multiplying 7 times the sum. In other words, we want to multiply 7 by the answer to the addition problem. And the only way we can multiply 7 by the answer is if we find the answer to the addition problem first. If we were to write it like this, 7 times a number plus 3, this would not work, because in this problem multiplication would come first and then we would add 3. We want to find the sum of a number and 3 first. According to what we learned in order of operations, if we make this have parentheses around it, that will make that come first. So now we will find n plus 3 and then multiply it by 7. So we're taking 7 and multiplying it by the sum of a number and 3. Sometimes we want to go backwards. Sometimes we're given something in symbols and we need to actually change it into words. This is just called reading the problem. So when I look at this, there's several ways I could read this problem. I might just say 8 plus a. I might say 8 increased by a. I could use more than, but in this case I would switch order. A more than 8. Those are just a few ways we could write that. For the second problem, we have m over r. Remember, this means to divide, so we could say m divided by r. We could say the quotient of m and r. Now remember, in division, order is important, so we want whatever is on top to be first and whatever is on the bottom to be second. So now we have a little multiple choice question. It says, which of the following expressions represents the sum of 16 and 5 times a number? So we look for keywords here, the sum. In other words, we're adding 16 and 5 times a number. The and indicates where the plus sign will go. These are the two things we're adding. We're adding 16 plus 5 times a number. That would be letter 3. Sorry, number 3. 16 plus 5 times a number. We've seen exponents before, but just as a quick review, when we see 10 to the third, the 10 is called the base, the 3 is called the exponent, or the power. We read this as 10 to the third power, or 10 cubed. It means we multiply 10 times 10 times 10. Since 10 times 10 is 100, and 100 times 10 is 1,000, then 10 to the third is 1,000. Now let's look at a couple of expressions that contain some exponents. 7 increased by 3 times a number to the 4th power. So we look again for our keywords. Increased by. That means addition. So 7 is going to be added with 3 times a number to the 4th power. So 7 will be added 3 times a number. We don't know the number, that's my variable. 3 times n to the 4th. So 3 times n to the 4th. Number 2, the product of 5 and the difference of 2 and a number cubed. Now this one can get confusing because of all the words, so let's just break it down. It says the product. That means the answer to a multiplication problem. So we're multiplying 5 and, so 5 times, the difference. Again, that's that little word that we need to be careful about because this means the answer to the subtraction problem. So we're going to be multiplying 5 times the answer to the subtraction problem. So we want parentheses again. 5 times, and we're going to create a subtraction problem in the parentheses. 2 and a number cubed. So 2 minus a number cubed. Now 5 is multiplied by the difference or the answer to that subtraction problem. So that's the end of today's lesson. Thank you for watching.